Alright class, here's video 4.1, solving systems by graphing. So we are doing system of linear equations here, okay? So we're graphing lines. And in unit 3, which was before unit 4 here, all we did was learn how to graph lines, graph linear equations. So we're going to have to be able to really be good with linear functions, so we can do unit 4, which is graphing linear functions and linear equations, and then doing other things with linear functions and equations, okay? So let's take a look over here at what is a system of linear equations. I gave you those notes in class. A system of equations, of linear equations especially, is when you have two or more equations using the same variables. The same variables most likely will be x and y's. And for math 1, we're only going to have 2 equations, okay? Sometimes you get 3 equations, but that's more advanced, maybe more a challenge one. But most of the time, we're only going to be dealing with 2 equations. And this is going to be lines, going to be linear equations that we're going to be graphing. And the solution for this system is the point that satisfies all of the equations. Both, in this case, is only 2. It's going to be both equations. We're trying to find this point where both of the equations that satisfy both of the equations. And this point, because it's a point on your graph, is going to be an ordered pair, a pair x comma y. Okay, so that's what we're looking for. We're trying to find a point where these two lines meet. And graphing will be one of the ways we're going to solve it. But when I graph it, there's 3 possibilities, okay? 3 things that could happen. Let's take a look at what could happen for possibility number 1. How about if these 2 lines intersect? Okay, I have these 2 lines over here. I have this down line over here, this negative line going down, and I have this positive line going up over here. It has a positive slope. Looks like we go up 1, up 1, 2, 3, run 1. So I have this line going up and I have this line going down. The point where they meet is the solution for these 2 lines. Okay, so if you give me this graph over here, I quickly see, oh, they meet at x equals 1 and y equals 2. So the solution for this graph is 1, 2. Okay, that's the solution for these 2 lines where they meet. That's what we're looking for. But how about if they don't intersect? How about if 2 lines never intersect? Well, if 2 lines never intersect, that means that they are parallel. Like 2 streets, they're parallel to each other and they never, ever, ever intersect. Like if you're familiar here with Fresno and Clovis, you know that Herndon and Alluvial are parallel streets. They never, ever intersect. So it's the same thing here with these 2 lines. As you can see, these 2 lines never intersect. There's no solution for these 2 lines because they're never going to meet each other. They're never going to intersect. Take a look at their slope. It looks like it's up 2, run 1, up 2, run 1. And I keep getting points on the line. If I keep going up 2, run 1, up 2, run 1, up 2, run 1 forever, I'm going to get this line. This other line over here also has the same slope. Up 2, run 1, up 2, run 1, and it goes forever. So they have exactly the same slope. The slope is up 2, so you rise 2 and you run 1, or just 2. They have the same slope, but they have completely different y-intercepts, as you can see here. This line over here touches the y-axis. This line up here is the y-axis, okay? This y-axis, this line over here touches the y-axis at y equals 2. But this other line over here touched the y-axis at -1. So they touch the y-axis at 2 different places, but they are at the same exact slope. They grow in the same rate, okay? So parallel lines have the same slope, but they have different y-intercept. They touch the y-axis in a different spot. So they never meet. They don't have an intersection. So there's no solution for parallel lines, okay? All right. How about if the lines are exactly the same and they're on the top of each other? Those are called coinciding lines, okay? Their lines are the same. So these lines are the same. Since they are exactly the same, they're on the top of each other right here. You can see I have one on the top and one on the bottom. They're both exactly the same line. If they are exactly the same line, they'll have exactly the same slope and they'll have exactly the same y-intercept. So they're just 2 different lines. they might not look, I'm sorry, they're two exactly the same lines. They might not look the same at first because one might be a little bit double of each other, but when you simplify it, you see that these two lines are exactly the same. So visually, you can see that they are the same lines. In the graph, you can see that they have exactly the same slope and the same y-intercept. So those are the three possibilities when we're dealing with graphing lines. They'll either be the same exact lines, they'll intersect because they're different lines, or they're parallel lines, they're never going to touch each other. So let's see, if you give me a problem and I looked at over here, graph these two equations. Equation number one, so this is our system right here, okay? Here's the system. I have two equations. I have equation number one on the top, and I have equation number two on the bottom. So let's take a look over here. Equation number one says 2x plus y equals 4. Some students like to put it in the slope y-intercept form, which is y equals mx plus b. They like this form because they can see the slope and they can see the y-intercept. So I'm okay with that if that is the approach you want to take. If you want to subtract the 2x to this other side, I can rewrite this equation as y equals the 2x is on this side. If I subtract it to this other side, I'll have minus 2x, but I already had a positive 4 in there, okay? So if I subtract the 2x to this other side of the equal sign, I would have this equation. So you see that the y-intercept is a positive 4. So let's go ahead and graph line number 1 at a positive 4. So this is a 1, 2, 3, 4. That is our y-intercept. This is my y-axis. Okay, this is my y-axis. So here's positive 4, and if I use the slope of drop 2, as you can see, this is a negative, so that means I'm going to drop 2, and is over a 1, invisible 1, so I drop 2 and run 1. So drop 2 and run 1 right here at 1, 2, and I'm going to do it again just to make sure I have 3 points instead of just 2. Drop 2 and run 1. There we go. So I have this nice 3 dots here. I can connect them. So let me connect them right here. And there is my line number 1. Okay? You can use any approach you want. Let me get a different color here to do the other line. Let's see if I have a different color pen here. Black. There we go. Okay? So there is my line number 1. Now let's take care of line number 2. Line number 2 says x minus y equals 2. If you want to put it in the y equals mx plus b form, I'm okay with it, meaning the y has to be by itself. So I'm going to subtract the x to this other side over here. So it's going to be negative, because the negative belongs to the y. Negative y equals, I subtracted the x, and I already had a positive 2 in there. So there we go. I would have that. The y has to be by itself, remember? So I need to divide by a negative 1 so I can get rid of this negative right here. So divide by negative 1, divide by negative 1, divide by negative 1. So we would have this equation now become y equals a negative divided by a negative is a positive x. A positive 2 divided by negative 1 is negative 2. Okay? So I just changed this equation to this form. Now, some students say, can I use the standard form? Absolutely. If you want to use the standard form on this, it's very easy, much easier than changing it into the slope y-intercept. I'm just trying to stay consistent with one type of strategy here. Okay, so now I have the y-intercept, which is negative 2. That's my b value. So negative 2 is down here. And my slope is this invisible number in front of the x, which is 1. Up 1, run 1 would be here. I'm going to do it one more time. Up 1, run 1, right there. Now I have 3 dots to connect my other line down here. So I'm going to connect these 3 dots right there. And there's my other line. So there we go. So they cross right here, both of these lines crossed at 2 for x and 0 for y. So where do the lines intersect? At 2 for x, 0 for y, at 2, 0. Okay? So if you want to check your solution, you can. You can go ahead and plug in 2 for x and see if you get 0 for y. So, I'm sorry, yes, this is 2 comma 0. So plug in 2 for x and see if you get 0 for y. 2 times 2 here is 4. When you subtract, you get 0. Yep, that works. And you can plug in here, and you see that you get 0 as well. So if you want to check your equation, if you want to check your point to see if it works, you can grab the first equation, 2x plus y equals 4. Plug in a 2 for x. See if you get 0 for y. Okay? 2 times a 2 for x plus y equals 4. 2 times 2 is 4 plus y equals 4. When you subtract 4 from both sides, y equals 0. It worked. Okay? So I just plugged in 2 for x and I got 0 for y. If I do exactly the same thing to the other line, x minus y equals 2. Plug in a 2 for x, and you can even plug in a 0 for y, and it will work. Okay? So if I plug in a 2 for x and a 0 for y, does that give me a true statement? Does 2 minus the x minus y, does that equals 2? Yes, it does. 2 equals 2 is a true statement. So as you can see, there's many strategies for you to be able to check to see if your points are correct. If you want to use the points in standard form to graph this, if you know how, go for it. Okay? So use whatever technique you learned from Unit 3, pick one way and stick to it so you can be good at graphing these equations. All right, let's do it one more time. Let's take a look at this other set over here. Graph the equations, and where do the lines intersect? Well, take a look at it. We have y equals 2x minus 3 and y equals 2x plus 1. Immediately when I see these two equations, equation number 1 and equation number 2, they already are isolated. I'm going to graph it because they're asking me to graph it anyway. So I'm going to graph it. It's already in the form of y equals mx plus b. They're both given to me already in the form. I'm going to use it. The y-intercept is -3. Right here is my -3. Okay, wait, let me move up a little bit. Right here is -3. And I'm going up to and running 1. Up to, run 1. And I'm going to do it one more time. Up to, run 1. I like to have more than just 2 points to graph my line. So there we go. It was a little bit off my grid because I drew this by hand. It didn't come out very nice. Okay, so here's my first line. If you want to, this is my line number 1. Okay? Now let me do my other line over here. Looks like I'm at y-intercept of 1 right here. That's my y-intercept of 1. But I'm also going up to running 1. Up to, run 1. Up to, run 1. And there you go. As you can see, you should have suspected right from the beginning because of the slope of these two equations. Okay, there we go. Okay, there we go. And this is my line number 2. You should have suspected right from the beginning the m value, which is the slope, is the same. These two lines are parallel. Okay, they're parallel lines. So they don't meet. Where does these two lines intersect? Nowhere. None. There's not a point where these two lines will meet because they are parallel. So there's no solution. You can write no solution. I can prove it to you by graphing it that these two lines are that have the same slope. If you want to even go further, you can have both lines have the same slope and give a nice explanation. Okay, so there you go. These two lines don't meet. They have the same slope. Let's take a look at another example. Here we go. What is the solution for this system? We have two lines. We don't know much about them. They look very messy over here. They're in different forms. It is up to you how you want to deal with these two lines. I'm going to label the top one number 1 and this bottom one number 2. I like to label them and keep them separately. So if you want to go ahead and rewrite them separately, I have 3x minus y equals 8, and I have the 2y equals 6x minus 16. Okay, two separate lines. You choose how you want to handle this. Whatever you're good with it. If you want to put it in the y equals mx plus b form, if that's the way you like to work on, that's fine with me. So if you want to do that, you would have to subtract the 3x from both sides. And you would have a negative y equals negative 3x. There's already a positive 8 in there. They're not the same terms, so we can't add them together. Now divide by a negative 1 so you can get rid of this negative 1 in here. Divide by negative 1 here and by negative 1 here. You would have y equals a negative 3 divided by negative 1 is positive 3x. A positive 8 divided by negative 1 is a negative 8. Okay? So we have that the y-intercept is negative 8 and the slope is positive 3 over 1. Rise 3, run 1. All right? If you wanted to do this in a different way, let me just verbally explain it. Finding the 2 points, you would replace as x with a 0, and you would solve for y. You would get 0, negative 8, okay? Because you have to divide by a negative 1. So you get 0, negative 8, which is our y-intercept right here. And if you want to plug in 0 for y, you would plug in 0 for y, and you would solve for x. You would get 8 divided by 3. So that is another way, is plugging in 0 for y, and you would get 8 divided by 3. It gives you an improper fraction, so that's kind of hard to deal with. So you choose which method is easier for you. Okay, so let's go ahead and graph this line number 1 here. Negative 8 is way down here. Let's go by 2. So that's minus 2, minus 4, minus 6, minus 8. So that is my y-intercept right here, negative 8. As you can see, it's my grid is, I'm going to go my grid by 2, okay? And I'm supposed to go up 3, run 1. So up 2 and 1 more here and run 1. It's going to be hard to make these lines meet right here because my grid is going by 2. 2, 4, 6, 8. 2, 4, 6, 8. Negative 2, negative 4, negative 6, negative 8. It's going to be hard, but let's try it. So I went up 3 over 1. I'm going to go up 3 again and over 1. So there's my line right there. If you have a grid better than me, use it. Okay? So there is my line number 1. Okay. Now let's take a look at this other one. All I have to do is get y by itself. So I would divide by a 2. Here I divided by a negative 1. Here I'm dividing by a 2. So if I divide by 2, I get y equals a 6 divided by 2 is 3. A negative 16 divided by 2 is negative 8. So the slope is positive 3. The y-intercept is negative 8. So it happens to be exactly the same line. It didn't look that way, but the y-intercept is negative 8. Up 3, run 1. Up 3, run 1. And there you go. It is exactly the same line on top of each other. Okay, I'm using 2 different colors, so you can see that that's my line number 2, and this is line number 1. They're exactly the same line. It didn't appear that way at first, but when you work it out, you got the same line. So, so you see those 3 examples where one is parallel, one are the same line, and when they intersect. I show you all 3 examples. Use your knowledge of graphing lines. And if you need a review of graphing, go watch my Unit 3 videos of graphing system of graphing linears. Okay, and then because we're using it here. So good luck with your homework. This is all about graphing 2 lines at the same time. Okay, on the same plane. So good luck.